So now we're going to apply our concepts of trigonometry and right angles and SOHCAHTOA, and we're going to use that understanding to solve real life problems. And this method, like these methods, are constantly used. You'll see people surveying on the side of the road. One person's at a transponder, another person's at a metered stick way over somewhere. They are calculating triangles, like they are using trig all of the time to do their jobs. So there are a lot of situations where trig comes into play. Okay, three primary trig ratios. What do we use? SOHCAHTOA. Remember, sine is opposite over hypotenuse, cos is adjacent over hypotenuse, and tan is opposite over adjacent. The Pythagorean theory is a squared plus b squared equals c squared. And then if you're a weirdo like me, you like it backwards. Yep. Yep. And then, because then I've got my unknown on the left-hand side, and we usually do things with the unknown on the left-hand side, and it's just nice when students see things that they recognize. So I actually write it out like that. Okay, we can use those primary trig ratios and the Pythagorean theory to figure out problems such as angles of elevation or angles of depression. All right, there is an important part of your eyeball. Oh my goodness, I'm going to draw an eyeball. It's happening. It's happening here. If I have an eyeball, there's the eyeball, and he's looking out, and he's like, oh, what's up? Okay, the eyeballs, when it's, and the ground is here, where they're going to be on the ground. This is how bored I am. Okay. So when you're standing there and your eyeball is looking straight across, you've created something called a horizontal. Let's pretend you're a cyclops. This is getting so off topic. You've created something called a horizontal. And the reason we call it a horizontal is because it's parallel to the ground and it creates a horizontal line. So your horizontal is where your angle of elevation or angle of depression can come from. So if I elevate, that means that I'm looking up from the horizontal. So my angle of elevation happens right here. One second, I've got to redo that color thing. This is my angle of elevation. And then similarly, if we have an angle of depression, it's when our eye looks down at the ground for something, the ant, the bug, the whatever, don't step on the dog poop, like whatever it is. We've created an angle of depression from the horizontal of our eyes. So when we go back to here and we talk about an angle of elevation, see how the horizontal comes straight across and it's parallel to the ground? We always have to create that horizontal. We're assuming that buildings, cliffs, towers, what else is it? Flagpoles, trees. We're assuming all of these things in these types of questions are standing straight up and down with the ground. So there's a 90-degree angle always created. So if the ground has a 90-degree angle here, if your horizontal that's parallel to the ground, it will also have a 90-degree angle. Okay, so that's an important concept to understand. Your angle of elevation is when you're the angle between the horizontal and the line of sight up to look at an object when you are looking up. And depression happens if you're standing on a cliff, like in this example, your horizontal still goes straight out. It's still 90 degrees to the cliff. There's a 90 degrees there. There's a 90 degrees there. Okay. And the depression happens here. and we've got to remember some Z patterns. Do you remember the Z pattern from grade 9? If we go, because this is parallel to this, let's do the Z pattern. Z, Z, Z. That means that this angle is the same as that angle, and that's important to know for our angle of depression. Our angle of elevation is the angle, and it's like right inside of the triangle that we need to use. And then our angle of depression, the angle is outside the triangle we need to use. So we have to use the Z pattern and put that angle down here. And we'll do it in an example, don't worry. So here's a tree, stands straight up and down to the ground. From a point 8.5 meters from the base of a tree, the angle of elevation. So if they're saying the base of the tree, it's elevation that's happening from the ground to the top. So we've got to go up to the top is 36 degrees. Find the height of the tree to the nearest tenth. How much is that? That's 1 decimal place, tenth of a meter. 1 decimal. For questions where you're given the information in a diagram, these questions don't feel that bad. But a lot of the trig problems that we run into for the word problems need you to make your own diagram. And that's where students run into problems. We're going to look at that in the next slide. So, given angle, where is it? Our given angle is right here. Where is the hypotenuse? Go across from the 90 degrees. This is our height. What else do we have? Let's go across from the given. This is our opposite, and then the only other one that we have is our adjacent. So, right angle triangle looks like a tree, but that's okay. Know where the 90 degrees is. Label all your sides, and then figure out, what am I going to use to solve this? Well, they gave us adjacent, and they're asking for opposite. So we have to use the relationship that has opposite and adjacent in it. So, that's tan, opposite and adjacent. So, tan of the angle equals opposite, which is x, over adjacent, which is 8.5. And how did I know that? Tan of the angle is opposite over adjacent. Tan equals opposite divided by adjacent. Okay. I'm going to do this math first. I want 4 decimal places on my calculator. So make sure you're in degrees. Tan of 36 equals 0.7265. 0.7265. And that's going to give us x over 8.5. Now we've got to get x by itself. That 8.5 is dividing the x, so we have to undo that. Undo it by multiplying by 8.5, multiplying by 8.5, and we should get 8.5 times 0.7265, 6.18, and then it wants us to round, so 6.1753. I'm just going to show you that. It wants us to round to 1 decimal place. So we have to keep this number. What does the 7 do to the 1? Even though there's stuff happening over here, we just worry about the number that's right beside where we're trying to create our decimal. So that 7 is going to cause that 1 to round up to a 2. So it'll be 6.2 meters equals x. This is a word problem, therefore the tree is 6.2 meters tall. I actually had to do this in university. This was for one of my courses, and we went out into the middle of the bush. We found a tree. We assumed it was 90. That was an assumption we had to make. Then we took a measuring. We created as straight a line as possible, and we measured it out, and we got the length. And then we had to get on the ground. That was kind of awkward, but you got onto the ground and you had to put your face like right down here and you had to tilt up your clinometer until the sight line hit the top of the tree, and you had to look at your clinometer to find out what that measure was. And we had to do it for like 5 different species of trees. So anyway, I don't know why I added that. Hopefully you